Okay, in this video lesson, we'll be looking at determining certain trigonometric functions of our special angles. All right, so let's just quickly review. If we're finding the trigonometric functions of special angles, it makes sense to just review the trigonometric functions. So from SOHCAHTOA, the 6 different trigonometric functions and their corresponding ratios from sine, cosine, tan, cosecant, secant, and cotangent. Next thing is what are our special angles that we'll be using here? Well, the special angles that we're familiar with, 30 degrees, 45 degrees, and 60 degrees. And so we're going to be combining what we know about the special angles. Well, what we know is our guide of Schur, using 1, 2 radical 3, and 1 radical 2 for 45, 45, 90. So we're going to use all 3 of these as our resources to do some of these problems. So here we go. First example says find secant 30 degrees. Well, because it's 30 degrees, we can start with the 30, 60, 90 triangle. And because we got a 30, 60, 90, we can use Schur to help us put some values on all 3 sides. So we'll have 1 for the short, 2 for the hypotenuse, radical 3 for the long. All right, and we're working with the 30-degree angle. So because we're working with the 30 degree, that means 1 will be the opposite, radical 3 is the adjacent, and the hypotenuse is 2. So using our resource, secant of any theta is the hypotenuse over the adjacent. Well, we can see in our figure that the hypotenuse from our angle is 2, and the adjacent is radical 3. So therefore, secant of 30 degrees is simply 2 over radical 3. But because the radical is in the denominator, this needs to be simplified. So we'll just rely upon our trusty calculator to simplify 2 over radical 3. So let's see. Simply, there we go, 2 over radical 3. Calculator should do it all for us. There it is, 2 radical 3 over 3. 2 radical 3, there we go, 2 radical 3 over 3. So we were able to determine the secant of 30 without using the calculator with any of the trig functions. Yeah, the calculator assisted us with simplifying, but we were able to do the trigonometry without using the trigonometric functions on the calculator. We'll do one more example. Find the sine of 45. Well, because we're working with a 45-degree angle, it behooves us to draw a 45, 45, 90 triangle. And because we have that triangle, we'll rely upon Schur to tell us what values to put on all 3 sides. So 1 will go on the short, 2 will on the hypotenuse. Well, because 1 can be on this side, that means we can also put a 1 on the other leg, because both of these legs are congruent. So let's say we'll work with that particular 45-degree angle as opposed to the other. So if we're working with that one, that means this one is opposite, that one is adjacent, and the hypotenuse is still radical 2. Well, if we're looking for sine, according to our resource, sine is opposite over hypotenuse. So opposite of this 45-degree angle is 1, and the hypotenuse is radical 2. So therefore, sine of 45 degrees is simply 1 over radical 2. But again, we have a radical in the denominator, so we'll use our calculator to help us simplify. So simply 1 over radical 2. Calculator says radical 2 over 2. So simplifies to radical 2 over 2. So for each one of the different problems, if you first draw the triangle, apply Schur, and put the values on all 3 sides, then you'll be able to complete any trigonometric functions ratio. Hopefully this will help you complete the Desmos.